Okay, here we are on day 40. In the math lesson, we're going to be looking at triangles. In 39, we were looking at quadrilaterals, four-sided figures. And of course, you know triangles are three-sided figures, but before we do that, we're going to go to our math windows first and take a look at those. So that's on what? Page 6 of 14. Okay. 6 of 14 math windows. Okay, what is the expression? What is the value of the expression? 3 times parentheses 2x minus y plus parentheses 3 plus x squared when x equals 4 and y equals 5. So this looks like it could be very complicated. It's got a very complicated expression there. But all we have to do is plug in the numbers. So it's not so hard after all. It looks complicated, but all you're going to do is put these values in for the x and the y. So this would be 3 times 2 times what? 4. Then minus the y is going to be 5. 2 times 4 is what? 8. Minus 5 is 3. 3 times 3 is 9. Plus, I'm having trouble with my focus a little there. Plus 3 plus x squared. X is 4 again, so we have 3 and 4 is 7 squared. What is 7 squared? 7 squared means 7 times 7. 2 7s multiplied together, that's 49. 9 plus 49. 10 and 49 is 59. 9 and 49 must be 58. Okay, onward. Number 2, identify the solution of the following system of equations. Well, we just did that a couple lessons ago. Systems of equations. So these are both linear equations that if you graphed them on a coordinate plane, you would get a straight line. This one you would get another straight line, and those two straight lines, unless they're parallel, they will intersect at a single point. Two lines, if they're not parallel, they cross at a point. And that's what we have to find. We have to find that point where they cross. And if it crosses at that point, that coordinate must work in that equation, and it must work in that equation. It must work in both equations. And there's a way we learned how to do that, to solve it. But since they're giving us multiple choice, we know one of these must be the right answer, so we can just plug them in and see if they work. So this is x, this is y. 6 is x. 6 and 4 is 10. Y is 10. Well, that works, but it also has to work in this one. It might work in one. It might be on one line, but not on the other if it's over here, for instance. Let's try it down here. The y is 10, so 2 times 10 is 20. The x is 6. 6 times 4 is 24. You get 20 plus 24. If you put that in your calculator, even if you don't, 20 and 24 is 44. This one works. Well, let's just check the others and see. X is 10. 10 and 4 is 14. That doesn't even work in the first one. X is 6. 6 and 4 is 10. That one doesn't work on the first one. 4 and 4 is 8. That one doesn't work. None of these even work in the first equation. We don't even have to check the second. A is the right answer. Okay. Now you could have solved this by doing what we learned how to solve a system of linear equations. And I'll do that real quick. Okay. So a good thing to do is substitution. If y equals x plus 4, we're going to substitute x plus 4 in the second equation. And then we'll be left with just one variable. 2 times, and instead of putting y, I'm going to substitute x plus 4. That gets rid of the y. And now I'm going to have only x's in the equation, and I can solve it. plus 4x equals 44. 2 times x plus 4, 2x, but you also have to multiply the 2 times the 4, plus 8 plus 4x equals 44. The 2x goes with the 4x, you end up with 8 plus 6x equals 44. Subtract 8 from both sides because we want to end up with just x. Well, get rid of the 8. 6x, we have to subtract 8 from the other side too, equals 36. How do we get rid of this 6? Well, we want it to be 1x, so we're going to divide by 6. 1x equals, you got to divide this side by 6, equals 6. Once you get the x, you put it back in the equation to get the y. 6 and 4 is 10. So 6 comma 10 is the solution. And that's what we already got. Okay? Again, you have to use your smarts. And if you don't remember the math, or if you want to do a fast way, sometimes just plugging in to find the answer works. Okay. A bag that contains 12 red, 3 blue, 6 green, and 4 yellow marbles. If a marble is drawn from the bag at random, what is the probability that the marble will be either blue or yellow? Well, there's 3 blue and there's 4 yellows. So you have 7 good marbles you can pick, blue or yellow. You just add the 3 and the 4. Out of how many marbles altogether? 12 and 3, 15, and 6, 21, and 4, 25. Now, if you put this in your calculator, you're going to end up with what? 0.28, which is also 28%. Now, it depends on how they write the answer. If they write it as a fraction, well, then you're done here. But you can see they used percent. So you would use your calculator and get 0.28. And remember, 0.28 is equal to 28% because 0.28 is 28 hundredths and percent is hundredths. You can move your decimal point 2 places to get the percent, 28 hundredths. And there it is, D. Number 4, what is the probability of choosing a green marble from a jar containing 5 red, 6 green, and 4 blue marbles? You have 6 green, and how many altogether? 11 and 4 is 15. 6 out of 15. Now, I don't know what the answer, if the answer was given in fraction, it might say 6 out of 15. They might expect you to reduce that. 3 goes into both of these numbers. 3 goes into 6. So if you divide by 3 over 3, 6 divided by 3 is 2, and 5 divided by 3 is 5. 6/15 is equal to 2/5. If you put it in your calculator, you would get 0.4, which is, if you move the decimal point 2 places, it would be 40, which is 40%. So it depends on how they give the answer. They might say 6/15, they might say 2/5, they might say 0.4, they might say 40%. Okay? And that is our math windows. Now, triangles. That's what we're working on, triangles. And again, I advise you to read through these pages because they do a good job of explaining what you need to know on triangles, okay? I know that it gives you a few definitions here. It talks about sides. You all know sides. Most of you know angles. Angles are that little part on the inside, the space between the lines. That's the angles. They use the word vertices. Vertices are the points where two lines come together are the vertices. A triangle has 3 vertices. And it uses this terminology. Triangle ABC refers to this triangle. Usually they like to put it in, well, they don't always put it in alphabetical order. Anyway, those are just some terminology, words that we use in math. Then it gives a classifying triangles, and there's 2 different ways they have classifying triangles. You might classify them by their sides. So if all the sides are the same, that's called an equilateral triangle. It has the word equal in it. Equilateral, three sides all the same. Almost the same as an equilateral triangle as an isosceles triangle. It has two sides are the same, but the other side different. And if none of the sides are the same, if they're all different, it's called scalene. This is one I certainly would not remember, but we'll use that term now because maybe they'll have it. I don't know. I don't know the word scalene, or didn't know the word scalene. Okay, that's by their sides. Equilateral, isosceles, and when no sides are the same, it's called scalene. Now, the other way to classify them is by their angles. So this equilateral triangle has all the angles the same. But what they're doing here is something called an acute triangle. An acute triangle says all angles are acute. Well, that doesn't tell you much. What it means is all angles are less than 90. No angles are 90 or bigger. What's 90? 90 is like this, like a corner of a room. That's 90. All of these angles are smaller than 90, so we call it acute. If an angle is bigger than 90, which angle is bigger than 90? That's smaller. That's one. This one here, 90 would be like this with that, right? But it's bigger than 90. That's called obtuse, when one is bigger than 90. You can't have two bigger than 90. You can't even have two that are 90, because if you have two that are 90, it adds up to 180. Here's two that are 90, like that and that. And you can see the lines aren't going to come together. So that's impossible. You can have only one bigger than 90, and that's called an obtuse triangle. If it's exactly 90, they draw this little box here, and they call it a right triangle when one angle is 90 degrees. So you have acute when they're all smaller than 90, obtuse when one is bigger than 90, and a right triangle when one is 90. Okay? What else? What kind of triangle? So they give an example here. Okay, what kind of triangle is this? Well, if you look at it, you say, well, they put that little box there, so I know it's a right triangle. It's not bigger than 90, and it's not smaller than 90. It's 90. So that's a right triangle. Right triangle has at one angle that's 90 degrees. And also they put 10 and 10 here. So these two sides are the same. This one's not 10. These two are the same, so it's an isosceles triangle when two sides are the same. Okay? There it says angle is a tight angle. I meant right. They put tight. Okay, and there it is. It's a right isosceles triangle. It's a right triangle and it's isosceles. Very good. Okay, is that it for this page? I think so. One more thing we're going to talk about today. We're going to break this lesson into two parts. In the second part, like we did with the quadrilaterals, the second part we're going to talk about perimeter and area of triangles, how to find those. For the rest of today, though, this lesson, we're going to be talking about the angles inside a triangle. And you might remember that when we did a quadrilateral, four-sided, let me put it over here. I'll do a rectangle, sort of a rectangle. It doesn't matter what kind of quadrilateral it is, so long as it's a quadrilateral, four sides. If you add up the angles, there's four angles. If you add them up, it adds up to 360. How about for a triangle? What do the angles add up there? Well, the angles add up here to 180. So a three-sided is 180. A four-sided is 360. A five-sided, like a pentagon, that's actually 540. And you can figure out a little formula for this, an algebraic formula for how to know how many degrees in a shape. And it goes like this. If you have n-sided shape, like a triangle is 3, right? You want 180. If it's 4, you want 360, which is 2 180s. And if it's 5, you want 540, which is 3 times 180. So you take n minus 2, So triangle has 3 sides. You subtract 2, you get 1. And what do? You multiply it times 180. So a triangle is 3 minus 2, 1 times 180. A quadrilateral is 4 minus 2 is 2 times 180 is 360. A pentagon would be 5 minus 2, 3 times 180, 540. And it goes on and on. Anyway, 180, that's the number to remember. What can you do with 180? Well, if you can figure out, if you know 2 of the angles, you can figure out the third by adding the 2 angles and subtracting from 180. If one of the sides, if it's a right triangle, that means one side is 90. 180 minus 90 is 90. That means the other 2 sides add up to 90. They can't be 90 and 0 because you can't have 0. But they add up to 90. If you have an equilateral triangle, that means all the angles are the same and they add up to 180. If you divide 3 into 180, you get 60. An equilateral triangle has 60, 60, and 60. And of course, it's also acute because they're all smaller than 90. Anyway, that's stuff to remember about. We're not going to be doing this right now, this part, because it's perimeter and area. We'll do that in part 2. Okay, so let's look at some problems here. So we can get through this. What's the directions here? Classify each triangle by each angle and sides. Base your decision on the actual lengths of the sides and the measures of the angles. Well, it doesn't tell us what the sides and angles are. We're just going to do it by eyeballing. Eyeballing means we're going to just look and see if they're the same or if they're different, okay? So look at this first one. These 2 sides look the same. Do you remember what they are if they're the same? Oh boy, I hate spelling this word. You can always go back to your classification page. This one here, right? 2 that are the same. Isosceles, 2 sides the same. This is isosceles. What is it? Oh, yeah, okay. Sometimes I forget how to spell these things. Isosceles. How about all the angles? Nope, this angle is a very big one. Do you remember what that is? Well, if you go back and look, that's obtuse. Isosceles obtuse, because one of the angles is bigger than 180, than 90. Altogether, they're 180. How about this one? Hey, this is obtuse also, bigger than 90. So we know it's obtuse. Do any of the sides look the same? Nope. All the sides look different. Tiny, bigger, biggest. When they're all different, what are they? Go back and look. Scalene. I forget if they say scalene obtuse or obtuse scalene, but we'll just put scalene obtuse. Okay, what number are we on now? Number 3. Let me make sure I'm doing this right. Okay. Yeah. Okay, so it's not drawing a little box there, but that sure looks like a right angle, doesn't it? So we'll say it's right 90 degrees, remember, like the corner in your rooms, most of them. And these look the same. It's isosceles. We'll put right isosceles, but it might be isosceles right. I guess it doesn't matter. It's an isosceles triangle because 2 are the same. How about this one? 2 are the same again. Isosceles. Oh, I did that wrong, didn't I? Ugh. Okay, let's do this again. Isosceles. And are any of them bigger than 90? No. When none of them are bigger than 90, what is it? Acute, right? Isosceles acute, because they're all smaller than 90. How about this one? Well, it's a right triangle again, and they're all different. None of them are the same, so it's not isosceles this time. It's a right scalene. A right scalene triangle. And this one, they all look the same, don't they? They all look the same. The angles look the same. So we'll call it equilateral, especially since they didn't do one. It's equilateral. They're all the same. And all equilateral have angles of 60, 60, 60, 60. So angles all 60, that makes it what? Acute. Equilateral. It's equilateral and acute, but you don't have to say equilateral acute because all equilaterals are acute. But not all acutes are equilateral. So maybe you should say equilateral acute. Okay. Classify each triangle. This time they give us the measures to make it easier. Okay. I think my focus is still a little off here. I don't know how to get it to focus. It's kind of a cloudy day out, so I'm not getting a lot of light in here. Okay. Anyway, these are all 60. The measures are all the same, so of course that's equilateral, and it's acute. All equilaterals are acute. Equilateral, acute, right? What else we got? Number 8. Okay. All the measurements are different, and all the angles are smaller than 90. So it's acute again, and it's scalene. We'll put scalene up here. Scalene acute. Scalene means they're all different measurements. Okay, number 9. That one looks like a right, and it does say 90, so that's right. And are they all different? Yep. So it's a right scalene. Again, because all the measures are different, all the sides are different. And this one's obtuse because it's got a really big angle. And these two are the same, 2.5. So it's obtuse. Obtuse, we were putting the angle on the, no, we're putting the angle on the top down. So we'll put obtuse isosceles. Obtuse isosceles. And that's it for page 9 of 14. These things do go on, don't they? Ay, ay, ay. I like to try to keep these lessons to under 30 because they take a long time to upload. Okay. Let me see, maybe if I move my camera, it'll refocus or something. I don't know. Okay. 4.5 or 4 point whatever, but it's the same as this one. Boy, it's having trouble focusing. They're all smaller than 90, and you got two that are the same, so you know it's isosceles. Two are the same. And they're all smaller than 90. That means it's acute. It's acute isosceles. Oh, it's acute isosceles. Isn't that chula? Okay. Another isosceles. You got two that are the same. Wait, is that same? Let me see. Oh, yeah. I can't see it that well because the focus is just getting worse and worse here. I think my camera's getting tired. It's pretty early this morning too, so maybe it's just a little groggy. He hasn't woken up yet. Okay. Isosceles, two are the same, and it's right triangle. So we'll say a right isosceles. Okay. Is this the same thing still? Class please try by each angle on sides. Ay, ay, ay. They keep going on and on. Okay. Acute, because they're all, nope, sorry, that's obtuse. So this is obtuse. And they're all different. Scalene. Obtuse, scalene. Isosceles. I left out a C, didn't I? Isosceles and acute. No big ones again. Or is this supposed to be acute isosceles? No, who cares? This one, right triangle. Yeah, right triangle. And they're all different. Right scalene. Um, this looks like it's the same as that. So that's isosceles, where two are the same. And because they're all smaller, they're not obtuse, they're all smaller than 90, then that's acute. Acute isosceles. I think we just did that one before. Here's obtuse. It's bigger than 90, but it's isosceles because these angles are equal and these sides are equal. Obtuse. Isosceles. And two are the same, and we got a right angle, so it's a right. Again, two are the same. Notice, by the way, if the sides are the same, the angles are the same. Isosceles. And that's the end of that page. Okay, now we have a little bit of working with the angles. Let's see if we can do this quickly then. Okay, classify each triangle in two ways. Oh, this is the same thing. 999, that's equilateral. And all equilaterals are acute because they all have 60 degrees. They're not bigger than 90. How about this one? Obtuse, bigger than 90. And they're all different. Obtuse, scalene. I hope you tried all these before you watched me show you, because it's not going to do you much good unless you can do it on your own. Okay, two are the same. This one's 68. Now, these, it's bigger than 60, so these have to be smaller than 60 because it would be 60, 60, 60. They're definitely not bigger than 90. So it's acute, and we got two that are the same. Now, since this is 60, whatever it is, 68 or 66, these can also be 68 because equilateral would be 60, 60, 60. So it's got to be isosceles, not equilateral. Isosceles, and it's acute. They're all smaller than 90. Okay, now we got some problems with angles, okay? So look at number one. How do we figure out that angle? Well, remember that the whole thing is 180. A triangle is 180. So if you add these two in your calculator, or if you can in your head, you would get 116, and you subtract to get the missing angle. 64 I got. 64, 64. Okay. Um, Now this one, they only gave us one angle. How are we going to figure out this one? Oh, that's a right angle. What's a right angle? 90. 90 and 45. Is that 45? 90 and 45. You add those two, 90 and 45, and you get 135. Then you subtract that from 180. 180 minus 135. And what does that give you? 45. Hey, that one's a right isosceles. 45, 45. That makes these two the same. And a 90. Uh, yeah, a right isosceles or isosceles, right. Okay. Choose the one best answer for each question. Question 7, 8, refer to the following figure. So we got this figure here, this big figure, and we got to figure out the answer to number 7. So we're going to make this a little smaller. Okay. If if angle DAB measures 115 degrees and angle DCB measures whatever that is, 95 degrees, what is the length of the side AC in centimeters? We're not even going to look at the hint. We don't need a hint. We don't need no stinking hint. Okay, let's try to figure this out. So it tells us angle DAB. Now, when it gives you an angle like this, the A has to be, that's the vertice, the one in the middle. So it goes like this. D, A, and B is, I think, up at the top there, right? Yeah. So that angle is 115. So this big angle here, DAB, is 115. And we know this angle is 55, this smaller one. So to find this other smaller one, that's one we want, we subtract 115 minus 55. If you put that in your calculator, you'll get 60. Oh, that one's 60. Okay. Now, what else did they tell us? DCB measures 95. DCB measures 95. So this here is 95. We want to figure out this one. 95 minus 35, because this is 95, the little one's 35. If you subtract them, guess what you get? 60. Why am I doing this, by the way? Well, we want to figure out AC. AC is that line there. And I'm wondering, well, how can we figure that out? Well, maybe they told us the angles so we can figure out the angles. If this is 60 and that's 60, what's the other one? Well, you could add them and subtract them from 180, but it's 60, 60, 60. It's a familiar one. That's an equilateral triangle, which means what? All three sides are the same. If we want AC, we just have to find another one. Here's another one. AB, what is it, 14? That means this one is also 14, as is this one here. But we want AC. That's the question. So the answer will be 14 centimeters. And there it is. Okay. Where do we go now? Number 8. What kind of triangle is ACD? ACD. Okay. ACD. AC. That's B. ACD. What kind of triangle is that? Well, we've got 55 and we got 35. We could add those two together. 55 and 35. If you add them, you get 90. And we know that a triangle has 180. So if we subtract 90 from 180, what is left over here? 90, just like it looks. This is a right triangle, 90 degrees. So it's a right triangle. And it's also different things. 8, 14, that's a different angle. So this will be a different number here. Scalene, but we want right triangle. Which one? It doesn't say scalene. We're lucky there, but it does say right. We figured out the answer, so right would be good. If it said scalene, we'd be in trouble. Okay. Number 9. One angle is a scalene triangle measures, one angle in a scalene triangle measures 38, and another angle measures 56. Scalene means they're all different. Okay, so one is 38, and another one is 56. What is the measure of the third? What do? You add them, 38 and 56. That comes up to what? 94. And what do you know? The whole thing is 180. So you subtract from 180. And what does that give you? Well, if you put that in a calculator, it should give you 86. Is it there? There it is. 86 degrees. Okay, that's it, right? So the next lesson, the second part of 40, we're going to be looking at perimeter and area of triangles.